Go.
Hey everybody, we're going to do some physics today. We're going to try answering the questions that you guys got wrong on the midterm. So the first question that I decided to do was on page 2, number 2. It's the first number 2. I think it's actually the only number 2. And so the question reads, a horizontal force is used to pull a 5 kilogram cart at a constant speed of 5 meters per second across the floor, as shown in the diagram below, or in this case, right here. If the force of friction between the cart and the floor is 10 newtons, the magnitude of the horizontal force along the cart or the handle is, and you have to choose one of the answers below. What happens is the answer is pretty simple to figure out. The answer is A, 10 newtons. Why A, 10 newtons? Because it tells you in the question, if you want you can even go and see it right here. It says the horizontal force is pulling the 5.0 kilogram cart at a constant speed. When something's pulling at a constant speed, it's almost as if it was going at 0. So because it told you the force of friction is 10, you have to basically balance it out. So 10, you have to make it 10 minus x is equal to 0. And you're basically solving for that x. So you do minus 10 on both sides. Negative x is equal to negative 10. So divided by negative 1 to make it into a positive. X is equal to 10, and the only answer that has 10 in it is A, 10 newtons. Hey guys, welcome back. We're going to do the next problem. The next problem is on the second page. It's number 7, and the question reads, the diagram below, which I've created here, shows a 10 kilogram mass held at a rest on a frictionless surface at a 30-degree angle, inclined by the force F. What is the approximate magnitude of force F? Basically, what is keeping that block from falling down? And so to find that, what you start is you have to create the separate vectors for this one. What this vector right here becomes, it becomes two vectors. Either it becomes a horizontal and a vertical vector. So the vertical vector from this exact point in the middle would just go straight down, which is also the force of gravity. And so the force of gravity is equal to the mass of the object times the acceleration due to gravity, which is 9.8. It's a constant. You're going to have to remember that number. And so it's 10 kilograms times 9.8, which basically means you have to move the decimal point over to your right one, so it becomes 98. And that becomes the hypotenuse of your new triangle when you go like this. You bring it also down like this, and create a 90-degree angle here, and thus this angle right here that you just created becomes another 30 degrees, because those two, it's another rule you're going to have to learn, that when you create that newer angle, the angle between those 2 points becomes the 30-degree angle. And then you want to find for this force of what's keeping it still. Now this force over here is going to be equal to this force, so whatever the value of that is going to be the value of that one. So what you have to use is your sign for SOHCAHTOA, S-O-H-C-A-H-T-O-A. You're going to have to use the sign part of this. So it's going to become, you're also going to have to use the hypotenuse. The hypotenuse sine theta method is equal to your force in this case. So you take your hypotenuse, which is 98, multiply it by the sine of 30, which I have no clue at the moment, and you should get your answer for that one. Now, so the sine of 30 becomes 1/2. You're left with 98 times 1/2 is equal to your force. 98 times 1/2, I don't know where to write this. 98 times 1/2 is 98 divided by 2. Which gives you the answer approximately 49. That gives you 49 in this case, but the only answer that's closest to 49 is 49.1. So I just basically made it 49.1, and so your answer becomes C. Hey there guys, welcome back. We're going to start with another problem. It is on page 4, question the first number 1 that you see on the page. Going from top to bottom, not on the bottom to top. Come on, read it correctly. And then, so it is the question, approximately how far will an object near Earth's surface fall in 3 seconds? So you use the equation right here. D equals VIT plus 1/2 AT squared. D, your distance, is equal to your initial velocity multiplied by your time plus 1/2 the acceleration due to gravity times the time it took squared. Now, you don't know your distance. That's what you're trying to figure out. So it's a question mark. Your time, it tells you, fall in 3 seconds. And so 3 seconds. Your initial velocity is 0, just because you start at 0. That's pretty self-explanatory. Unless you're you start at 0. And then for your acceleration due to gravity, it is one of the things you need to remember about Earth. Earth has an acceleration due to gravity of 9.8 meters per second squared. Okay, let's start filling in the problem here. D is equal to 0 multiplied, which is your initial velocity, multiplied by 3, which is your time, plus 1/2, 9.8, which is your acceleration due to gravity, t, which is your 3, squared. This will cancel out. 0 times 3 is 0, so we'll just cancel out because 0 won't make a difference of how anything is added. 1/2 of 9.8 is 4.9. 4.9 times 3 squared. 3 squared is 9. 4.9 times... Sorry, my handwriting is very sloppy. 4.9 times 9 should give you your distance. And when you multiply it out, you get, that's 81. 9 times 4 is 36. 36 plus 8 is 44. 44.1. Now, that answer isn't on the actual test itself. It's close, though. You can find a number. The closest number you can find is 44. And so basically, you can just round it and it becomes your answer, which is, surprisingly, D is equal to 44. All right, guys. The next question we're going to do is number 20 on page number 4. Question was, an object falls freely from rest near the surface of the Earth. Sorry. What is the speed of the object when it has fallen 4.9 meters from the rest position? That was a trick question. Don't look at it. Whenever you see free falls from Earth, free falls to Earth, 9.8 meters per second squared. That is your answer. I'm not going to tell you anymore. The answer is D. That's it. Too bad. I don't care.
Go.
The next question we're going to do is also on page 4. It's number 3. The question reads, the diagram below, which I've illustrated here, shows a block sliding down a plane inclined at an angle with the horizontal. As the angle is increased, the coefficient of kinetic friction between the bottom of the surface of the block and the surface of the incline will... Again, a very tricky question. It doesn't, when you're talking about coefficient of friction between two items, it doesn't matter the angle that it's at. What happens is, no matter what this angle is right here, no matter what this theta is, whether it's 0 or 90, where it's basically like that, the coefficient between this surface right here and that will always be the same. Because it's not asking you what's happening with the angle, it's asking you what's happening to the coefficient of friction. What's happening to how much friction there is between it. That's never going to change no matter what your angle is. There's always going to be that constant coefficient of friction between those two items. And so the answer is B. It will remain the same. The next question we have is on page 5. It's number 7. The question reads, as a meteor moves from a distance of 16 Earth radii, so I'm going to draw it out right here. So this is the Earth. I'm going to make it with an E. If it goes from 16 Earth radii away, this is the meteor. I know I'm not an artist. 16 fine. 16 radii to 2 radii. It says when it goes from a distance of 16 Earth radii to a distance of 2 Earth radii from the center of the Earth. So they're both being compared. So sorry, that's not the center. The E is in the center. The magnitude of the gravitational force between the meteor and the Earth becomes what? Now the way you figure this out is you'd use the gravitational force equation, or what is it? Yeah, the gravitational force equation. And so I'm not going to write it out right now, but it's telling you, all you need to know is mass of the objects and the radius between them. or the radius of those objects. And so what's happening here is the mass is going to be the same, and so you'll cut out the mass from that kind of equation, and you're left with the radius, the radii. What you do is, my own personal trick that I found is, if something is getting closer together, the gravitational force between them is getting bigger, and if it's going farther apart, it's getting smaller. And so what happens is, you want to have a fraction where your numerator is going to be larger than your denominator, because that means the force is getting bigger because it's getting closer to Earth. So you do 16 squared, you take the square of that number, and then you take the square of 2 squared, each radius squared, over each other, and you should get, I'm sorry, that's wrong, you would do 16 over 2 squared. So you do 16 over 2 would give you 8. 8 squared gives you the gravitational change of the force between, that the meteor had, which is 64 times, and that would be answer B. Answer B is equal to 64 times greater. Alright guys, we're going to be on page 8. It's question 22. The question reads, 1,200 kilogram space vehicle travels at 4.8 meters per second along the surface of Mars. If the magnitude of the gravitational field of Mars, so if the gravitational force of Mars is 3.7 newtons per kilogram, the magnitude of the normal force acting on the vehicle is, and you have to plug in your answer. And so basically here, what you can do is, you might want to see this, you can just basically wipe off your acceleration, or you can wipe off the vertical motion, because force normal and force gravity only has to do with vertical, and because it doesn't say that this is moving vertically, it said it's moving horizontally, not vertically, you can just erase that entire part because it's not going to matter one single bit. And so what you do is, because what you're basically trying to find is your force normal, and your force normal is equal to your force gravity when it's not moving vertically, which it is. And to find the force gravity, is F is equal to mass times the gravity of that place, which in this case is 3.7. 3.7 times the mass, which is 1,200, and should give you your force. Your force should be equal to 4,400, or anywhere close to that, so your force of gravity is equal to 4,400. And because you said over here, your force gravity is equal to your force normal, that means your force normal by process should equal to 4,400, giving you the answer of 3. So the next question we're going to do is on page 8. It's number 23. It says, base your answer on the information below and the accompanying vector diagram. I've just made it really big for you guys right there. So a dog walks 8 meters north and then 6 meters due east. So he's now over here. He was here, and now he's there. So, using a metric ruler and the vector diagram to determine the scale used in the diagram. So I measured each of these parts on my own graph here. I measured it in inches, and then I did ratios and stuff like that to get my values. And I found that a single inch on this paper, not here, this is just a blown up version of it, the 1 inch is equal to 3.2 meters. And that is your answer. That should be your answer to part A. Part B, I'm going to show you in the diagram. It says, on the diagram, on your answer sheet, or on a separate piece of paper, construct the resultant vector that represents the dog's total displacement. So what displacement is the straight line between 2 points. And so he was here, and he ended here. And so basically, the straightest line between them is right here. Or, sorry, you can't draw straight lines. And that becomes your resultant force, your displacement force. That is your answer to part B. So I'm just going to make an arrow there saying look over there. And now part C, it says determine the magnitude of the dog's total displacement. The way you figure out for the total displacement is, I'm going to bend down here because I'm short, I'm too tall. What you do is use the trigonometric equation that everyone should know. A squared plus b squared is equal to c squared. And now you just have to, you would have replaced each of the a and the b to find the c value, which is here. So this would be, let's just say that the a value is 8 meters and the b value is 6 meters. So you would plug in for those numbers. 8 meters squared plus 6 meters squared gives you c squared. You get 64 plus 36 is equal to c squared. I should sit down. Then you add these together, you get 100 is equal to c squared. You find the square root of each of these values. And you should have c is equal to 10 meters. And that is that. Alright guys, the next question is 24 on page 8. The question reads, a soccer ball is kicked. A kicked soccer ball has an initial velocity of 25 meters per second at an angle of 40 degrees above horizontal level ground. The first part is, A, calculate the magnitude of the vertical component of the ball's initial velocity. Show all work including equations, yeah. So, we're going to start off like this. A, it said it was kicked with a velocity of 25 meters per second at a 40-degree angle. And now you're going to try to find this part over here. And so what you use is, you use your SOHCAHTOA again, C-A-H-T-O-A, and then it becomes, you're going to use to find the opposite over the hypotenuse. The only one with opposite over hypotenuse for this angle is sine. So you use this equation. Hypotenuse sine theta is equal to your d of y. Yeah, that makes sense. Your d of y is your vertical component. So your hypotenuse is 25 multiplied by sine 40 gives you your d of y. Sine 40 times, when you multiply that out, your answer, you get your d of y is equal to 16. I need an eraser. 16.07 meters per second. That's part A. Now, stay with me here. I'm going to erase everything except that. You get that down? If you didn't, just keep looking at it. Now it's gone. Next part B. Part B for this equation. Calculate the maximum height of the ball. Reaches above its initial position. So initial position was that starting position we had originally. It's going to go into like an arc shape. And you're going to have to find. All right, now we're going to work on question number 24 on page 8. It says a kicked soccer ball has an initial velocity of 25 meters per second at an angle of 40 degrees above the horizontal level ground. First part of that is A. Calculate the magnitude of the vertical component of the ball's initial velocity. Show all work, including equations. Substitute with units. Okay. Make a triangle. It says 25 is your initial velocity of the kick. And it's going at 40 degrees. 25 meters per second, 40 degrees. You use SOHCAHTOA, S-O-H-C-A-H-T-O-A. Because you have this and you want to find the vertical component, which is this side over here, you're going to find the opposite of that over the hypotenuse. The only one that has that is sine. You use the equation H sine theta is equal to your d of y. You plug it in, 25 sine 40, and you get your d of y. Then your d of y, when you plug that in to a calculator, which I don't have at the moment on me, becomes, if I can find my answer, it becomes 16.07 meters per second. Take a second to look at all that, and you will have your answer to part A of that question. Now that you guys have taken a second to look over that, we're going to basically erase all of this because we do not need it anymore. All we're going to need to know is, for part B, we're going to need to know this question over here. Now part B tells you to, what does it tell you to do? I have no clue. Part B tells you to calculate the maximum height of the ball reaches above its initial position. The initial position was that starting position. I'm going to create that triangle again. That's your initial position. You want to find, it's going to create an arc. You want to find the highest point on that arc. It's not going to be exactly that, but we'll just say it is for now. You're going to find the highest position. What I decided to do is, because it's an arc, I decided to think, let's think a quadratic equation. And so I made this into one of the values and plugged it into the formula D is equal to VIT plus 1/2 AT squared. Your initial velocity is this one right here, so it's 16.07 because your initial velocity in terms of maximum height is only being determined by your y direction. I'm going to make time equal to an x plus 1/2. Your acceleration is due to gravity, which is equal to 9.8 meters per second squared. So you just leave it as 9.8, make it x squared, and that should look somewhat like a quadratic equation you put into a calculator. To make it a little bit clearer for you guys, it becomes 4.9 x squared plus 16.07x. I plugged that into the calculator, did a few things on the graphing part of it, and found your answer to part B to equal to 13.17 meters high. So your answer should be there or around that area. That's your answer. Okay. Now you have the part. Now you have the answer to two parts of that problem. The third and final one you have on the diagram. On your answer sheet or on a separate piece of paper, sketch the path of the ball's flight from its initial position at point P and until it returned to level ground. So what you have to do is you have to find when you find on that the graph, you're going to find it looks something like that. You're going to have to find this point at the x value for that one also. You just have to find exactly what the x value for is. It should tell you on there when you find the maximum point. And that will be, your x value will be your time. To find the total time, you multiply this x value by 2. And that will give you your total time of how long it took to get from this point to that point. When I did it, it was a total time between 3.0 and 3.5 seconds. And then I graphed it on an interval of each of these is 0.5 seconds. So it's 1.0, 1.5, 2.0, 2.5, 3.0, and 3.5. Again, sorry, very sloppy. And then what I did was I went up these by an even number. I went up by 2, 2, 4, 6, 8. Who do we appreciate? No. 10, 12, and 14. And then what I did was I plugged in each of the values, each of the x's, into where the time would be in the equation. D is equal to VIT plus 1/2 AT squared. So your initial velocity was 16.07. D is equal to 16.07. Let's say I wanted to use the time of 0.5. Multiply that by 0.5 plus 1/2 of your acceleration, which is 9.8. Multiply that by 0.5 squared, and you get your answer of between 6 and 8. Now, there's a trick on the calculator where you can find all of these values. So basically that's what I did, and I just plotted each point. So I'm just going to roughly plot it out here for you. It looks like that. This one goes between here, and that one's like here, or something like that, and it's all the way down until it hits like about here. It's a rough estimate, and then you draw it. and then basically you just created exactly, you found out what the path of that ball, when you kicked it at a 40 degree angle at what is that? A vector initial velocity of 25 meters per second. You figured out the exact path of the ball. You found out how high the highest point is going to be. You also found out what the y the y value is in terms of speed. Perfect. Finally, the last one I'm going to do today, and you're not going to have to sit through. The last one is number 25. The accompanying graph represents the velocity of an object traveling in a straight line as a function of time. Determine the magnitude of the total displacement of the object at the end of the first 6 seconds. Now, it says it's the end of first 6 seconds, and you're only looking for the displacement. So, between 6 and 8, bye. A lot of people got tripped up because it said 8 seconds. I saw it right away. I crossed it out. I didn't cross it out on my paper, but I knew just to not look at it. And so what displacement is the velocity divided by the time. So it's all the answers underneath this part. This area right here is the displacement of the object. So the way you find it is you break it up into 2 parts. You're going to break it up between 0 and 2 seconds and between 2 and 6 seconds. So between 0 and 2 seconds, this leg has a value of 2. This leg has a value of, from point here to point here, has a value of 10. So what you do is you use to find the area of this one triangle right here. Sorry, I don't have different colors. The area of a triangle is equal to 1/2 base times height. A of triangle. So the area is equal to 1/2 of the base, which is 2, the height, which is 10. 2 times 10 is 20, 1/2 of 20. The area of that is equal to 10. Next part, you have to do the area of this square, if I can somewhat outline it. You have to find the area of that square. So it's between 2 and 6. 6 minus 2 is equal to 4. So the entire thing of this is equal to 4. The entire one of this one is equal to whatever the height from here to here is, which is 10. To find the area of a square, or in this case it's a rectangle, you multiply area. So it's area of a square is equal to base times height, or leg times leg, whatever you want to call it. So area of that square is equal to 4 times 10. Area of the square is equal to 40. To find the area of this entire thing, you add the 2 areas together. 40 plus 10 gives you 50 meters as your total displacement. And I'm done.